Hello, my name is John Capobianco, and I'm going to be giving you a tour of Asynchronous Python. Now, this is an evolution for me, and as you know, I may or may not know, I started with Ansible in about 2015, 2016. I self-published a book called Automate Your Network in 2019 about Ansible and network automation. Around the same time, shortly after the book, I started to use Python, PyETS, and different Python libraries. What I'm going to show you today uses the Cisco ACI APIC, which is a software-defined networking controller. And the thing about ACI is that everything has an API associated with it in the management information tree, the MIT. So what we can do is make requests against the APIC and get back structured JavaScript object notation, JSON, as the payload from these API calls. Now, if you look in my videos, I did a live stream, it's about 2 hours long, on building what I call ACI, EYE. And what my goal is to scrape a bunch of APIs and make files. I call them business ready documents because they're business ready. There is a JSON file, a YAML file, and then I use Jinja 2 templating to make a CSV file, a markdown file, a data table powered HTML page. So it's not just an HTML table, it's interactive and dynamic using cascading style sheets, CSS, and JavaScripts, JS, to enhance the basic table. So you can search and sort and paginate and move columns and make PDFs and send it to your printer. All kinds of great stuff. Finally, I make a mind map, which is just markdown in a particular format that uses the MarkMap VS Code extension to view these mind maps. Now, in my first iteration, I was using the requests library, which is pretty easy to do. You can do this with Postman. You get an API call working, show code, and then pick Python requests, and it will give you the request code to run in Python. Now, requests is blocking. It is synchronous. Make an API call, wait for the response, take the response, make the next API call, get the response, back and forth through all the APIs, and then make the files. This turned out to be slow, really slow. It takes, in the sandbox, and I'll show you how you can use this code, the DevNet sandbox, it was taking 15 minutes, 16 minutes. In some fabrics where people were using it live in production, big fabrics, it was taking 40 minutes, 30 minutes, almost an hour, which means it wasn't really enterprise grade. It was kind of not even worth running because it took so long to run. Can we make this faster? Well, using asynchronous, non-blocking code, we can go get all the API data from, I have 250 approximately APIs from APIC. Go get all that data, non-blocking. Give me the data, give me the data, give me the data, give me the data. Just go and blast it and give me all the data back. Then make the files and template the files non-blocking. Don't wait for anything else, just do it. And this, it's not just faster. I was expecting to shave a few minutes off of the runtime, maybe from 15 minutes to 10 minutes or 5 minutes. It's unbelievable. It's not just faster. It's an entirely different experience, and you're going to see this. I have it down to 35 seconds. Seconds. From double-digit minutes to double-digit seconds. It's like a 2,700% improvement in performance. In this video, I'm going to show you all of the code. It's open source code. It's on my GitHub. It's on PyPy. I'm going to show you how you can use the code, and we're going to run it live to show you just how fast this really is. So, to summarize, we went from the requests library, synchronous blocking code, like a COBOL batch job, one by one, to asynchronous code, which is non-blocking and everything can just work in parallel tasks. Little workers that do all of this asynchronously. Don't wait for anything else, just go ahead and process it. So let me switch to my code and let's take a look at the code. So I've collapsed everything and we're going to tour through this. But in terms of what I'm importing into my Python, I'm still using requests, and I'll show you where I'm using requests. But these are the three important asynchronous libraries: AIO HTTP, Async IO, and AIO files. The other thing I'm going to show you is in the Jinja 2 environment, how we can transform our templating from synchronous to asynchronous. Because this is kind of an all or nothing thing. Nothing can be blocking. We don't want to wait on any process. So I don't want the bottleneck to be at the templating where it's serially, sequentially blocking the rest of the activities. The other thing is files. When I'm creating the files, same idea. I don't want to block while it's making the files. I want to create these files asynchronously. So the other libraries I'm bringing in is JSON and YAML, and I'm using urllib3 to disable warnings because I'm using the sandbox uses a self-signed certificate and I don't want that warning. Now I'm using rich click to make my command line interface program, and you don't see it in here, but I use poetry to package all this up and make it available to you on PyPy as a pip install package. And you're not going to see too much of the poetry. So I'm going to go to the bottom of the code, and this is the rich click. And we use these click decorators, and I'm saying ask the user for the URL of their APIC, their username, and their password, and then invoke my class of ACI, passing in those three parameters the user provides. Finally, kick off my ACI function. Within the click options, we have our prompt, I can have help, and we can set it to be required. And I love this, we can set up environment variables, and I'll show you how that's done. Now, in terms of the code and the functions, I do my init, my initialization, where I'm setting up self ACI, self username, self password as those three parameters the user passes in so I can reference them later. Now I'll show you my ACI function in a second, but to show you get token, with ACI you need to do a post, passing in the username and password, and what we get back is a token. And that token is a cookie. So this little function returns the response.cookies. And here I'm just using the requests library. This is not asynchronous, which is fine because it's a one-time call to get the cookie from our authentication. Now in ACI, what I'm doing is calling my make directories. And what make directories does, it goes through this API list, all of these APIs, and it creates folders for the output. That's the whole purpose of this little function, is to just set up the folder structure to store the output. Okay? So we have all of these APIs, 250 approximately. Now, the next thing I do is register self.cookie as the response, the return cookie from that get token function. Now we get into the asynchronicity. I call asyncIO.run, and I'm going to asynchronously run my main function. Now let's take a look at the main function. And the main function is going to use async IO. And what I want to do is, and you can see here, these functions, they're all just like normal Python functions, except instead of just defining the function, I'm going to say it's an asynchronous function. So what's going to happen is, in main, I'm going to call getAPI, and we'll come back in a second, but it's more than that. What I'm saying is await, just wait for async IO to dot gather, and then I splat or asterisk my getAPI function. Now what I'm doing is I'm saying pass in the URL for a for loop here, each API URL in that list that I've defined here. So loop over the list and go get each API, passing the URL into this getAPI function, but do it asynchronously. Do them all. Just go get all that data. Then I await, the keyword await, wait for that async to come back, and I call this function called allFiles, which is a JSON dump of the results here. Now, what is in results? Well, results is going to be a massive, massive list of all of the JSON returned from the API and a little bit more. And I want that in a JSON dump. So dump the string to JSON and, indent it for and sort the keys. So before we look at all files, let's look at getAPI, which is this function here. So I'm saying asynchronously with AIO HTTP client session as session. So set up an asynchronous session and async with session.get, similar to requests.get or requests.get. And what am I going to get? Well, I want a formatted string with the ACI URL they pass me, and then the APIC URL, which again from the list is this bit of the API call. So combine the path to the APIC with the path to the URL, pass it the cookie so we're authenticated, and I do this as resp or as a response. Now what I'm doing is setting up response dictionary, and this is the key here. And it's going to wait for this response.json. So go and get all of the API data and stuff it into response.dictionary. Now I just print the status code of each API call so we can see that we got a 200 back. Now this is important. What I'm returning from this function is, yes, that massive dictionary, that massive list of JSON responses, but accompany it with the URL. So asynchronous can give us the calling API and the corresponding JSON dictionary, and do this asynchronously. Once this has awaited, results is going to store that URL and the dictionary in one massive list. Pass that along, the results, pass it into all files as JSON. Now let's take a look at all files for a second, and this is really neat. All files does another async gather, right? I don't want anything blocking here. And what am I going to do with asynchronous gather? Make the JSON file, the YAML file, the CSV file, the markdown file, the HTML file, and the mind map file asynchronously. Just go ahead and start making files from the data once the data has come back. Now, before we get into the files, let's take a look at these other functions. I'm calling physical interfaces prefix list details, and tenant health. And I do this because let's look at physical interfaces. Again, it's another async AIO HTTP client session. and it's all asynchronous. But in the APIC, certain paths are dependent on parent paths. So go get all the nodes, go get all the ACI nodes, and then for each node in that list of nodes, call the node dn / L1 physical interfaces and build up an empty list of physical interfaces. And what are we going to return, right? We're going to append each of those responses into this empty list, and we're going to return the URL and that list of payload. Now again, this is also asynchronous. So I do that for, tenant health is the same thing. Go get all the tenants and then go get all of their health and return it as a list. So now let's take a look at the files. And there's some important points to make here. So for JSON file, what I'm going to do is parsed JSON is this results, the massive list of every API's response and the corresponding API. So I'm going to do a little for loop here to say for the API and the payload in the JSON loads of that parsed JSON list. And I'm just checking if certain strings, like if tenant is in the API, if tenant is in the path of API, then asynchronously, and this is async here, use AIO files and write that payload as JSON, right? So I don't want this blocking. So it's another async call. We're awaiting the write and we're using AIO files. So none of this is blocking. Now for the YAML file, more or less the same thing, except I'm YAML dumping that JSON payload to give me the YAML file. Again, using AIO files asynchronously, awaiting the write. So don't block anything. Now, this is another important point. I love Jinja. If you know anything about me, Jinja 2 is my hammer and everything is a nail. Well, how can I turn on asynchronous for my Jinja 2 so it's not the bottleneck, so it's not blocking? Well, when we set up our environment, we can add enable async equals true. So my Jinja environment is now asynchronous. And the only thing different about when we render our template is that we're going to render it async. Render this async. Don't block anything. Just render it and await that render async. Once we have rendered our template, right, CSV output is the rendered Jinja 2 templated version. Use the async AIO files and write that CSV output to a CSV file. So again, we don't want Jinja blocking anything, so in the environment, set up enable async and render asynchronous. All of that was found in the Jinja 2 documentation, and it's a slight tweak, but before I did this, my Jinja was my bottleneck here. Similarly, if I was just doing regular file writes in my JSON file, that would be a bottleneck. And that's the code. Now, for the sake of completeness, if you want to look at what I'm doing in the Jinja, let's go to the top. This is the CSV Jinja. So if, FV subnet is in the API, then make a CSV file with the different attributes for that particular API and make a CSV file. Now my HTML, I include another Jinja 2 template, my header at the top, and another Jinja 2 template, my footer at the bottom. So let's quickly look at those before we proceed. My header calls all of these scripts and all of these style sheets and puts them in the header of each HTML page. And then I open up the body because this is going to be included for each of these templated pages. My footer is a pretty complicated JavaScript that took me time to figure out over time. but I'm really happy with this JavaScript, and I more or less reuse these headers and these footers from datatables.net to create my data table powered HTML table. The markdown is just like the CSV, except we use pipes and we have a delimiter, and that makes a markdown table. And then the mind map, well, it's just nested ampersands, nested pound symbols, headers, and we can do up to 6 levels of depth. And then this will render in the mark map extension for VS Code. So that's the tour of the code. Pretty straightforward stuff. It's more or less a rewrite of my requests. Now let's take a look at this live. So what I'm going to do is go into my and activate my ACI virtual environment. I'm going to go into ACI testing, and it's full. Well, to prove I'm not cheating, let's delete everything. So this is an empty folder. And what you can do is pip install ACI, and I'm going to do -u here to upgrade it, and it's already satisfied. As of this video, the version of ACI is 2.0.1. So how can we run this? Well, if I do ACI --help, it gives you the help. So I could do ACI --URL, put in the URL, --username, put in the username. I could just run ACI interactively, and it will prompt you for the path. What I really like to do, though, so I can run this a lot without this interactivity or without passing it parameters, is to export, username equals admin, export password equals, and let's go into the sandbox, and I'll show you where to find this sandbox. So we go to the DevNet sandboxes, and you can do this at home. You can run this yourself. And what we want is the always on ACI simulator right here, the second one, ACI simulator always on. And we're going to grab the password and the URL. And this is even slower than my asynchronous code. Okay, so just a second here. We're going to load up. Okay, so what we want over here is this password. We see the username is admin. We're going to grab this password and export the password. Actually, it needs to be in single quotes because there's special characters in the password. And then export URL equals, and we're going to take this URL. Now, let's get ready for the magic here. So we're going to run time ACI to time it. And when I press enter, boom, it's just asynchronous. Go get all the API data. Go get all of it. And right now, this little pause, it's asynchronously creating all of the files in the background. Then it's going to move on to those other functions, tenant health, interfaces. Here we are on interfaces, asynchronously. And, go through each of the prefixes. There's no prefix lists. That's just a text warning because there's no prefix details. And then go get all the JSON health. 37 seconds. 37 seconds. "37 seconds of real time, 30 seconds of user time, 0.09 seconds of system time." And what do we get? Let me shut that magnifier back off. Where did it go? Okay, so now here is all of the data that we get. Every one of these folders, and let's look at physical interfaces because I like physical interfaces. I have my CSV file and VS Code. I can preview that. And look, any interfaces down? No, they're all up. Right? Using human readable business ready files. And look at all these fields. I could say, show me the interfaces just for node 102. Show me all of the interfaces. What is the ether type? Are they all 33024? Yes, they are. There's just so much data in here. Are there any layer 2 interfaces? Yeah, show me the layer 2 interfaces. Show me the layer 3 interfaces. Right? And, right, any link flap errors? Are they all MDIX? Are they all broadcast? When was the last modified interface? We can sort that by last modified. Anything that's an accident, no, they're all trunk ports. What's the MTU? Well, some of these have different MTUs. Anyway, I'm not going to spend too much time on the output. It was more about the asynchronous, but it created 1,450 files from 250 plus APIs in 30 seconds. I don't think you can even log into an APIC in less than 30 seconds. You certainly can't find all the data you need in 30 seconds. This completely documents your entire ACI fabric in 30 seconds. So, if you're still doing requests, I urge you to take a look at asynchronous code. It took me a couple of days, I'm going to be honest with you. A lot of failures, a lot of trial and error. What about this? What if I try that? Why isn't this working? What's going on? I'm getting all my data, but my files are slow. Change that to asynchronous. Okay, everything's fast. My JSON files are fast. My YAML files are fast, but my templated files are slow. Change the Jinja to asynchronous. So now this is completely non-blocking code using the asynchronous abilities of Python. So I'm going to be rewriting all kinds of libraries that I've done. I've done a lot of Git repositories. My next step is going to be ICE. And I'm more or less going to copy and paste my ACI code, replace the list of APIs to be the ICE APIs, rewrite my Jinja templates for my ICE data, and hopefully ICE will take even less time, right? There's maybe 100 APIs, I don't know how many, but we're going to fully document ICE, Identity Services Engine, using their APIs asynchronously in just seconds. Huge, huge thank you to Jeremy Schulman, who I reached out to Jeremy. He volunteered to help me with this. He pointed me in the right direction. He gave me lots of good tips. If you Google Jeremy Schulman, John Capobianco in YouTube, he did a live session that I recommend you looking at. He really goes into asynchronous code. The other thing I want to say is that you can figure this out. You can use my code. It's on GitHub. It's really easy to do, and it is so much faster. Not even close. 15 minutes, 30 seconds. 2,700% improvement in performance. Keep an eye out for some live streaming. I'm going to be live streaming my ICE development. And thank you for watching the video. And reach out to me if you have any questions. Let me know what you think. Spin up a sandbox and run the code yourself. Try it in production. This is safe to run. It's just gets. I'm not changing anything about the APIC. I'm just documenting it. So this code would probably work, will work against your data center fabrics. Thanks again. We'll see you soon.